Hi everyone, Prem here. So welcome back to the channel again. Last time we deployed locally LLM locally, and we ran the model locally, and we were able to chat with the LLM, which is deployed locally in our system using Docker image. So the next we're gonna do is we are gonna build a chatbot using the LLM which we deployed locally using Docker container, and we're going to interact with the model using a UI which is going to be like Streamlet UI. So we can use Streamlet, which is a very powerful tool for the UI development using Python. So let's use Streamlet tool to develop the UI for the chatbot, and we can connect. We can try to hit the backend, which is our model, which is deployed in the Docker container. So the first question which might come to your mind is, how are we going to interact with the model, because it's deployed inside the container, right? So let's check our GitHub repository, a README file. So last time we did this video, so we deployed a Docker container using a Olama, which is a powerful tool again. So we deployed it using a port forwarding rule. So here we did the port mapping, so where we can map the host port with the container port. So that also Olama has its own REST API exposure, so that we were able to curl. If you remember, we were able to curl to the local host to the particular port where we exposed with the model in the prompt, and we were able to see the response in a stream of each word by word. We were able to see it as a stream, right? So this is up to the this is what we did in the last video. So think about, like, I was thinking about how to integrate this with a chatbot and use it as a UI, so that we can chat like a ChatGPT or some custom chatbots. So for that, so since it's a curl command, it's also like a post API. So it's a post request with a response body, which has model and the prompt in the prompt as a parameter. So let's try to hit this from the postman and see whether we are able to get the response or not. So first thing first, let me see whether my container is running. Yeah, my container is running as we did last time. If you are new to this video, I would kindly request you to watch the previous video, so that you get the context of what we are working on. So we deployed this Olama container last time, so it's currently running. So we can first test, and we can first test our curl command. So what we are going to do is, we are going to test the same curl command from a postman, and let's see what output we'll be getting. Are we getting any response or not from the postman? And so you guys can also remember that we did a custom model, which is an agent for a particular company's customer support. So we are going to use that particular model, not the Llama 3. So let me first open the GitHub repository. So the first change we did is model file. So this model file has a few more context about the company, like what services it offers. So last time we had only this line stating that this chatbot is responsible for answering as a customer support for this Kefia private limited company. So after that, I have added the context for the model to understand about the company, what services it offers, and what are the pricing model it offers, and it can also schedule what are the availabilities for scheduling demo. So this chatbot can answer questions about the company's services and the pricing model, and it can also schedule a demo meeting with the experts to see the demo of their services. And these are the context I have added. So after adding this, we need to build this model again using this model file. So we need to build it, and we'll be able to access it using the API. So I have did that already. So docker ps, so just running here. Let me get into it. Okay, if you see the model file, let me just cat it. Yeah, so I've updated the model file, and I've created using this command which we did last time, which is Olama create agent using the model file, and I also tested it by running Olama run agent. So let's just test this from Postman and see what happens. So currently the model file which is here uses Phi3 mini, which is we are using from Olama, which is developed by Microsoft. I choose this because it is lightweight and we can get the response much faster than the Llama 3. So it has, I believe it has 3.8 billion parameters, and it's very fast than Llama 3. So I choose this particular model for this chatbot project. That's why I used in my model file, you can see that Phi3 mini. So let's try from the Postman now, and if you see here, it's same URL which we curl from. So it's from localhost port and then /API/generate, and in the body we passed it as JSON, which has the parameter model, prompt, and stream. So this stream, where did it come from? So I have read in the documentation. So let's go there in the documentation. So in the Phi3 documentation, you would find API documentation link here. I see. This API is common for all the models, not particularly from Llama. So this is common for all the models. This is provided by Olama. So this is like a documentation for that API exposed, which we were accessing using the curl command, right? So we were accessing this curl command with model and prompt, but now we need, like, if it is a chatbot, we need our chatbot should be able to print word by word. When we ask some questions, it should print word by word in a single chat. It should not be like each word for one chat, right? So for that, we can control that using this particular stream parameter, which is by setting it as true or false. It's a boolean. So if we set it as false, it won't give us as a stream. It gives a whole output after the whole generation of the text. So after it gives the whole output of the model, not by word. Okay. So for now, from the Postman, we'll just keep it as false, and we will hit the model now. So currently we are hitting Phi3 mini, just Phi3 mini, not the custom model which we built. So the custom model name is agent, right? So it's not Phi3 mini. So let's see what it does. So if we are able to make this work, if we are able to see the response in this, we can integrate with this any UI using any framework. We will be able to integrate it. Yeah, we got a response. So in the response, we see the model created at and the response, and the whole response is in the parameter response, and we see done is true and done reason is stop, and we have the context also, and we see other metadata like total duration, load duration, and etc. So using this, we will be able to build a chatbot. So what's the next problem I faced is this stream falls. Like each and every time when we ask anything to the chatbot, it takes some time. We saw that when I hit send in this Postman, it took like 5 to 10 seconds to respond. So the user should wait for this whole response to come. But we can use stream as true and see the output word by word in the chat itself. That makes user to see what the chatbot is replying word by word. That makes user more interactive than waiting for the whole response. So let's move on. Let's move on to the readme file. So these are the features which are there in the chatbot. It's streaming a response from the backend API, so it's not word by word, like it's not the whole response at a single time. It's going to stream word by word, and we are going to capture it in the chat. And suggestion question, like we are going to show some suggestion questions that user can ask the chatbot, and maintain the context. So we are going to maintain the context of last 5 messages for each prompt, so that the model can understand the context of what the user has been interacting with the chatbot before, so that it can answer accordingly. And user friendly interface, like we have a chatbot which is developed using Streamlet. Okay, let me run the application. Before that, let me just discuss the model file. So in the model file, we have some more interesting things to see about. Other than the information about the company, we have something here at line number 46. We have said that we have informed the model that this Agentina can only answer questions related to Kefia Private Limited services, pricing models, and demo scheduling. If any other question out of topic, it's just going to say a warning message stating that I'm sorry, but I can only assist with the queries related to the Kefia Private Limited services. So we are not going to take any other questions. So our model can answer any questions, not only specific to Kefia Private Limited. But our chatbot we are not going to concentrate on other things other than about the company. So this chatbot is particularly developed for the purpose of being a customer support for a particular company called Kefia Private Limited. So it's going to only answer those questions, not other questions. So this I wanted to highlight. And so this is the app.py, which is built using Streamlet. This is the code for the UI and the backend call logic. And if you see here, we would call the backend API, which is the local host, and hitting the container port, the host port, which is mapped to the container port, which is running in my local in a Docker container, with stream as true. So how did we handle this stream as true in this chatbot? So we handle it like until we saw that in the response we have a variable done. If done is true, you see here, until the done is true, we are going to append each word in a single chat instead of printing each word as a separate chat. So that is what I did here. And here if you see, we are passing, for now I've changed it to, from 5 messages I've changed it to 2, because it was taking a lot much time if we pass last 5 messages as a context. So I have passed last 2 messages as a context. So it takes previous 2 messages as a context message, and it sends into the prompt. If we see here, it's a full prompt. The full prompt contains the context and the question the user asks. Okay, let's come back to the code after we see the application which I built, chatbot which I built. Let me exit from the container. So let me start the Streamlet app. So this is the chatbot which is built using Streamlet UI, and the backend, it is the local LLM which is running on my Docker container in my local machine. So first it shows the some suggested questions, and we are going to select what KFIA offers. So what are the services it offers? It's going to give us the services it offers. For initially, for the first question, it takes some time because it tries to load the model, and then it answers the question. But after the first question, I was able to see that it is much faster than the first question. Yeah, so the assistant is answering, so we are able to see the output like word by word streaming here, and it's been recorded in a single chat, and we will be able to answer only after it completes. So the speed of this response depends upon the system power, like the host machine's power or processing power. We can make it faster by deploying it in the cloud. So that will be our next video, next step, also a next video. So we'll be deploying it into a Kubernetes cluster, and we'll be having some powerful machines behind it, so that it can be very faster than this, much faster than this. And we're going to ask, can you schedule me a demo? Help me to schedule a demo. And it's going to give me the availability, and we can also test the edge case, like if I'm going to ask some irrelevant question and see how it responds. So now it's going to give me the schedule, like availability schedule, and I'm not going to give any context, and I'm just going to say Wednesday 11 p.m. and let's see that whether it is able to get the context and say able to schedule a meeting at what time I'm giving. Like let us type Wednesday 11 a.m. Let's say, how about so since it has the context of the previous message, it should say that, yeah, so it knows the context, and it scheduled the meeting for me, and it's going to send me an email for the meeting link. Okay, now let me ask some random question. Tell me about Boston. This is not related to the KFIA or anything else, but now it should not answer for this. It should not say about anything about Boston. It should just show the warning message. Yeah, it is showing the warning message that it can only answer questions related to KFIA Private Limited. So that's it for this demo today. So the enhancement would be making the performance better by customizing the context which I am giving for each messages, and deploying it in the cloud for the better compute power. Let's see in the next video that deploying this in a cloud environment, and let's see how fast it can answer for each question, and let's see how what different types of model, how it behaves in the cloud. Since we have our compute power in the cloud, we have a ability to test multiple models and even higher models which has higher number of parameters, and we will see that in next video. Thank you so much for this. Thank you so much for watching until the end. Let's see in the next video. Thank you.